So last week we covered a lot. We've already done, we did the install Spark, unzipping the Spark using this, and also reading file, how to use Spark section, builder.app name, get or create, getting file paths. I guess if you are struggling with getting these folder paths, in case you are uploading from here, you can go here, go to this edge here, just do copy paths. You'll be able to get the path. If I paste the path now, you'll see the path. So just put it inside here, then put double inverted comma, you'll be able to get that. So, but in case you are using this, it's more easier. When you run this, just load it, then put the name there. It will catch it. Now, so we read our file. We used counts. We were able to count the rows in the data. I showed you I opened the file, the CSV file, and I showed you how it was done. Print schema, which is the column. Then I explained non-partitions. I also explained how to use coalesce to reduce, like I said, Spark normally do parallel processing of data. So if it sees that the data is a very huge data, it will assign it to workers and they will split it and they will do the work and collate the files together. So while they are dividing it, the file will come in partitions. So you can decide to group all the files together as a full file. So you use coalesce to do that. I explained how to select, we want to select column, maybe few columns in your data. For example, we're selecting middle age, children, and adults. Here, we already know the number of columns that we have. We have early underscore name, this, that's 1, 2, 3, 4, 5, 6, 6 columns, 6 different columns here. So, but we're selecting 3 columns. The effect of selecting 3 columns is, number one, it helps you to filter the expected data that you're interested in. Number two, it increases the efficiency when it comes to performance. It's very, very important. So sometimes the data, we intentionally start from the beginning to filter out wherever we don't want. Because by catching that from the beginning, you make the system to be very more faster. So in this case, I will assume that this is an example of it. We only selected 3 columns. Maybe we are interested in the three columns, middle-aged children and adults. We're able to select that. And we did, our normal count through the rows. Then I also explained, using select, different ways of using select. Number one, you can use the actual name of the column using data df. Remember, data df is from here. Don't let us forget our data frame here, which is spark.read.format CSV option header equals to true. We use header equals to true because the data has contains header. If we don't want to use the header here, then we can say header equals to false. Then it will exclude the header. Then we can create our own header. So data df here, then you use for select the name of the column that you have, children, don't forget inverted comma, adults. I think if we use single inverted, it will still work. But let's stick to double inverted. So if we run that, then here we can decide to show our data frame dot show. Then we can see the only selected columns are now shown. So we have the data here. These are the figures. So now, let's go to the next line. I don't really want to spend time on this because I've already explained. So it's going to affect our overall time at the end of the day. So let's try, I will try as much as possible to manage the time while I'm trying to go through what we did last week. So that's the count. So this one we count the rows. So we already know how that works, which I explained last week. Then we want to do select using different way, like call. So we can pass in call, but for us to use this call, we need to import this module from PySpark.sql.functions import call. So this call, so it's just like we are using select here, the same select, but we're now passing in call, passing the column name, comma, call, then the other column name, then call. So it will still give us the same results. It will still give us the same result that we have here. I deleted it the other time. Dot show. So it will still give us the same result. Can you see? The same result. It doesn't make difference. So you can select in different ways depending on what you're doing. Sometimes I've seen a situation where I decided to use this and I was like, oh, in some other situation, I had to use this. Yeah, so just know different way of selecting that will make it to be a bit dynamic and a bit logical when it comes to application of all these selects. So we have data underscore select show, which I've shown you. Then another way to select is use data underscore there, which is the data frame dot select again. Then you will now pass in the name of the data frame dot the column name. The data frame itself dot the column name, data frame itself dot the column name, data frame itself dot the column name. It will still do the same thing. You get the same answer for this. So I've shown you like 3 different ways. Then another one is you use column dot import column. You import this module called column. So when you import that module, you'll be able to select all the columns. So in this case, let me do data frame. So I can do something interesting here. Let's print. If we print this one out, so let me do for I in df dot column. Okay. So now I just did something. You know, we're using columns. We're using these columns now. So what I try to do is that I try to create a list of all the columns that we have here from the data frame. You know, remember the data underscore df. This is the actual data underscore df, which has 1, 2, 3, 4. If you want me to show this data underscore df dot show. So data underscore df dot show. You see, these are the columns. So in our case, we just want to filter out these columns. We want to filter out all the columns. You know, the benefit of this, imagine your columns are a bit dynamic when it comes to reading of data. When you are using columns, dot columns, you don't need to manually add code those column names. So you just use dot columns to select all of them. So where are we? Okay. So dot columns helps you to select all the columns without stating the name of the column. You know, in this case, we're saying data frame, data underscore df dot middle age, data underscore df dot adults, data underscore df dot children. We specifically mention the name of the column. But in this case, we don't need to mention the column. We can dynamically, you know, select the column using these dot columns. And I've shown you now. So let's say, let me take this off now. Let's print this. Let's print this. If we print this, it's showing the column. Can you see the f dot column? So it's still the same thing like a list. It's creating a list. So if I want to do that, I can just apply I for I in this. I'm still going to get the same list. So this is what we call list compression. So we're looping through the df columns to get these lists. So, but you can decide to use this, but it makes sense if you do that in case you want to specifically loop and create a condition. So now this will catch all the columns we want to read. And if you want to filter out any column at the end of the day, you can. But in the case that you're expecting different data frame, just like, for example, you want to read several files that are of different columns. Files that are of different columns, you will be able to use this df.columns to do that. Now, I will show you what I was trying to I've been trying to explain. Now, let me explain it this way. Let's divert a bit. Okay, let me divert a bit. So let's say we have, let me see if I have any. 1 second. I'm coming, just trying to check if I have any CSV file here. So okay. So let's say I have this CSV file. This CSV file, I've decided to create additional column. Look at this column. I've decided to create an additional column. So this additional column, 1 second. So let me do, oops. Okay, let me just create the column like this. Let me say this is the column. So let me do anti. Oh, okay. So take this off. So I want to create a new column in this case. So I'll say anti ID. Then you understand what I've been trying to explain. Let's say this one is middle age. Age. We have children. Then we have, let's say, adults. Let's say this one is, we just call it elderly, and this is percentage. Remember, I'm adding another column. So this is the column, new column. Now let me save it. Extra UK data, extra data. So let me grab the file now. Let me grab the file from here. I'm going to delete this new. So UK data, extra data, UK data, extra. Okay, so these are our extra data. So now copy paths. So let's say we have, okay, brilliant. So now let's say we have these file paths. This is extra underscore paths equals to string. Let's pass it as string. So then we have the other one for data paths, which is equal to the one that we're dealing with, which is this. So we can decide to copy it from there. So I'm going to use something like this. Let's copy this. Let's go down. Just want to explain why I said it helps you to dynamically select column. So in this case, oh, sorry, in this case, okay, no worry. So I've selected this. I only, if you go here, you can select that, just copy parts, it will still do the same thing. So if I do this copy parts, it's still this. Can you see? So it doesn't make difference. So now we have this now here. So now we have, oh, okay, that's fine. So let's go up again just to do spark.read. So I'm going to copy this. I'm going to copy this. So I can decide to do like this. So we have, let's create a function. Oh, sorry. No, this is not what I want. Okay, let's say we want to create, let's say def. Now you understand what I'm trying to say. So read file, read file, read file, this. Read this file. When you read this file, return this. So, but when you read this file, read file underscore name, good. File underscore name, spark equals to, sorry. Yeah. So return this file name. So we can pass in file name here. So we pass in the file name here. So 1 second. So we have this. So this is our file name. This is the file that we're interested in. Can you see the file? Can you see? So return file name. So if you want to dynamically read this file now, we can now do, okay, let's do it this way. We can do read file name, passing the file that you're interested in. Say, let's say, for example, we have extra parts. Okay, I won't do it that way. Sorry. Let's do it this way. Let's do it. This is data frame equals to this. Then let's do data frame dot data frame dot columns. Brilliant. This is better. Now, so now we can do read file now. So our read file, we can pass in our file name now here. So let's pass in our file name. This one, extra parts. Pass in extra parts in this case. In the other case, read file again. Read file, pass in data parts. Good. Let's pass in data parts. So now let's run this. Read file, read file. Can you see? So what this one is doing, if I put print at the back, we don't really need print because we're returning. So it's giving us this. So if I do print at the back, we have that. Can you see? So because we've said return df.column. So if I run this one also, if I put print at the back, can you see? Can you see the same? We're using one function to read columns using df.column. So in this case, the columns are county ID, middle age, children, adult, elderly, percentage. While the other one is early underscore name, early underscore code, middle age, children, adults, this. Does that make sense? So with one function, you are able to read the same file. You just pass in the name of the file. Does that make sense?
Yes, sir.
Please, if you don't get it, let me know. Okay. Let me do another thing for you. You remember when we started the looping, for loop? Let's say this is a list. You can create this one as a list. Now you should be getting when I was explaining for loop, how to use for loop, you should now understand something here now. So here we can decide to say, okay, for 5 parts, 5 part in extra parts, print 5 parts. So let's say the 5 parts. So file. So if we run this, we get our 5 parts. Can you see? For 5 parts expired. So it's printing how many words? It's printing 5 parts. So we can decide to read file with these 5 parts and use this function under it. So you can decide now to use this function under this. So you can use read file function under this to read the file dynamically. Why this one can move up? Does that make sense? Or is getting complicated? Is that getting complicated? Hello? Okay.
So we're here.
I think
Watch the
it's
video
making
again. So
sense.
If you have been watching that video from the beginning, you'll be able to understand. I was talking about how to read file dynamically and stuff. Okay, anyway, let's take it back. So I think I've been able to pass my message across. Please, do you mind muting? Okay, yeah, that's fine. Thank you. Now let me take this off again. So let's just stick to what we've been doing. So so
So I'm not hearing you. Are you talking?
sorry, 1 second, please. I was trying to attend to something a few minutes. Sorry for that. So I'll continue from here. So I think I deleted something the other time. So which is a read file part. So let me take it back. 1 second, undo, delete. Yeah, deleted that file part. Undo, delete, 1 seconds. Okay. I'm just taking it back to grab wherever I did before. So I'll return it back to the normal. Okay. Okay, sorry. Take it back. Okay, so let me just okay, good. So don't worry, I will use this one. Normal, so let's take this off. So I explain one as extra parts, extra parts equals to this. So the other one I explained as I said should be data parts, data underscore parts equals to this. Okay, good. So we are back to the previous step. So now we have this. So I've shown you how to data column, and I said how to read different files in different parts. Oh, I've deleted something now, which I have to recover back. Okay, anyway, but I can type it down. So now this, then you remember we created a function. So I said df read file. So let me rewrite it. Read file, and I say read file, we take the file parts. So file parts. Now file parts, I said file part will be Spark equals to, so I can do data frame equals to Spark dot read our format CSV file dot can use depending, we can do your dot load, but we have to use header because in this case we added our header, so we use option header here. So format here, spark dot read dot format. Let's go back. So spark dot read dot format CSV. The format CSV header equals to true, then passing the file parts here. So we'll call it file parts. Good. So now, after doing that, then we applied our read file parts and this. Good. So we're back. So we see we're using the same function to read different files, and we are getting different columns. The idea behind this is to help you to dynamically process your data separately. Imagine you using this function now, you're using it to read file. So I can decide in this situation to write this file, this data frame, into different folder paths. Does that make sense? So let's do something like that. And that was why I was trying to tell you that when you're reading function, when you're using for loop and the rest to read your file, it helps you to dynamically save your file. It reduces the time that the code we use to process, because you've been able to use your Python logically to process the file faster, the files faster. So in this case, we have applied extra this, we have applied this. So we can at the same time use that for loop and say if file is this, she should just do this, and it will send it to different destination. Am I making sense? And that was what I was trying to say, do the other time. I was trying to explain how to dynamically read this file, read the data frame, and write the data frame maybe to a specific destination. But we've successfully shown how we can apply this function to read columns differently by passing the file name. So we're using the same function and we're passing the file name. So we've been able to achieve that. So let's go on. Then we have another way. We can use select.columns, and we can manually select the column between the range. Remember index. I was talking about index. First element, second element. I said first element is index 0, second element when we're talking about list. This is an example of list. This is 0, index. This is index 0, index 1, index 2, index 3, index 4, index 5. So in this case, we are selecting from 0 to 4. So it's going to be 0, 1, 2, 1, and 3. Remember, it's not going to select 4 when it comes to range, because this is range. You're using start and end. So the start value will not be selected, which is children. So young people will not be selected, but to stop at children. Does that make sense? If you go back to the video where I was talking about data structure, you will understand this better. So this is the application here. And we're able to select only how many columns? Only 4 columns using that data structure that we covered initially in the beginning of the class, rather. Now we have this, so we can do this and we read our file. So here, just like we read our file here, we have three columns. You can decide to select only 2 columns. So we do 3 columns also. We can do 3 here. If you apply 3 here, then we select only 3 columns. Let's run it again. Can you see 3 columns? So that's the select statement. I explained with column how to use with column. With column is to convert your data to the expected format. Imagine you have data that comes with as string, but you can, after checking the figures, you discover they are all should be an integer. So, like for example, this is an integer. You can't count this one as integer because it's a mixture of letters and numbers. So this is an ID, so you classify it as string. So this is a string in this case. So in that case, you need to understand that you need to convert this particular one to an integer. And this type of integer is not single integer, so you call it double. It's either you use a double or you use a long. So sometimes you use double or you use long. Long means we have more than 1 digits. So in this case, we have double. Double, is 1 3 from 1 3. So long, you can use, in this case, you can use long to do the transformation. And from here, we have with column, we try to cast this middle age to what? Middle age from the main data frame. Remember, we are not using this. So we converted middle age, we cast it to what? Integer type, children to what? Integer type. Then we have with column, young people, it's an integer type, but you can decide to use double type. You can decide to use long type. The main reason why you can dynamically use integer, double, or long is that you only need it in case you need calculation. But you can't leave it in string. You have to convert it from string to integer because you can't multiply string together. It's not possible. So you can only multiply numbers, and to make this a number, you have to convert it to integer type. It's either integer type, a double type, a long type. I don't actually recommend a float. The reason is only if your data has got a float. If you check your figures and you discover you have floats there, so you can use float type. Float is like you are accounting for anything in decimal points. So that's the work of floats. So now let's go on. So we have print schema. So we are applying this now. We've imported this module, integer type, this and that. So we are applying it here. I explained last week. It's like we're just going back. So now we have this is being converted. Can you see integer from string here? It was initially string. But with this, we're able to convert it to what? Integer. I can decide to change this one to double. Let's see what is going to happen. Double, and this one double. So if I do this one now, let's run it again. Let's see. Can you see it's been converted to what? Double. But one good thing is that if you are doing multiplication, addition, subtraction, you can still do it with double or long or integer. Does that make sense?
Yes, sir.
Thank you. So let's go on show. So we have new data now. So can you see double? In this case of double now is giving us .0, which is not bad, not bad. So it looks like a float. So you can still work with that. It doesn't affect your calculation or whatever. Now, here we have middle age. I think I changed middle age to float here in this case. So let's see we have float. It's just to test, you see, it's been converted to float. And let's see the appearance of floats. Floats, middle age, can you see it's like double also, .0000. But float is good when you have decimal. So you can use that. Then here, I use with column just to change our column. Initially, our column here is early_name. So I apply with column rename to change our column from here. This is the current one. This is the new one, from current to new. Then after doing that, we're able to change the name to this. We also covered concatenation. I explained concatenation, like, for example, you can apply concatenation to join first name and last name together. Let's say I have first name and last name separated, but I want to combine them together as one. So you can use concatenation to do that. Lit is to create add code. Sometimes in data engineering, we do add coding. We do add code figures, especially when we know, let's say, for example, we're doing in the course of development, there is a specific data we are expecting from a stakeholder or data provider, and we are not getting it. But we want to test our application to make sure it's working fine. What do? We mimic or improvise, find a way to create a similar data that we're expecting. So then we continue with our work. So, and to do that, you can use leads. So use leads. Here, I'm creating a new column, data column, and I pass in United Kingdom. Maybe the data I'm dealing with is United Kingdom, so I can just pass in United Kingdom to create a new column for that. So I've done several projects that I use leads to add code a value. So now that's leads, which we've seen the results. Concatenation is to join two stuff. I've explained that. So if you have first name, let's say this one is first name, this is last name, you can combine them together to have first name and last name together. Or another example is, let's say you have a postcode and address shown in different columns. What you will do is that you use concatenation to join them together. So concatenation, you will create a new column, passing the concat. Remember, you need to import the module concat. So in Spark, you import module. So concat. So this is the column, the first column you want to join with the other column. So the first column is early_name. Remember the name of the data frame here, which is this data frame here, the data frame here. So dots. Remember how we're selecting columns that I showed the other time. So that's what we are applying here. Change_data type_df dots. Remember, dots early name. Does that make sense? So this is how to select a column. So in this case, we're selecting this column. Then we do leads. So leads, we pass in, we are combining the concat and leads. So when you are doing concatenation, you can combine with leads at the same time, because leads helps you to put anything you want to add code. For example, we want to add code this now. We want to add code this sign. So we put leads, then comma. So comma, you put the column, the first column you are interested in, leads to add code any sign you want to add in between, then the other part of the column, which is this. That's why you have this one here. Now it's done. So we can decide to make a space. If you want to create a space only, just click this and it will create a space. Can you see Darlington, United Kingdom? If you want to put comma, put comma like this. You see comma space. You see there is a space there. So it will keep that space. Can you see comma United Kingdom? And this is how to deal with data. Now we have, okay. So I think this is also the same thing, concatenation. So we created, in this case, I only had coded United Kingdom. So I used lit here, the first column and lit. The first column here and the lit. So I showed that example again to give us something similar to this. So now, in this case, we use data column that we have created. But in this new one, I didn't create this one. I only use LA name, the lit. They are passing the United Kingdom, including the comma here. See the comma here? Comma, space, United. So instead of doing it this way, I can decide to use this method just to do comma space without mentioning any new column here. Remember, that saves, in terms of performance, I see this code is better than this. Because in this case, we created this one first before doing another one. So, but in this case, we chose the first column, then passing the United Kingdom directly instead of going through two different steps. Does that make sense? So let's go on. Does that make sense?
Yes, sir.
So this code, this one is better than this. Because in this case, we created a column before concatenating. In this case, we didn't create a column, we only lit directly and we concatenate with this. Good, okay. So let's go on. Print schema. So we've printed the schema and we can see the results show. So we go to, okay, we've done data type also. So I don't think I need to cover this again. I don't think I need to cover this, but what I did here was that, let me see the difference between them. So difference between that data type is that, remember I use select data frame dot middle age. So data frame dot column, but in this case, I decided to use the column itself, the column name directly. I pass in data df, then pass in the column name, then use cast. So you can do things different ways depending on the application, but you remember the select that I explained. So this is just part of select. You're choosing a column. You can decide to do dots here, dots middle age. Remember? Dots middle age like this. So instead, I change the method to cast this file into different type by using this method of select. So now let's go on. So I think I don't really need to buttress on that. So let's go on. Then we have column renamed LA underscore code. So that's been explained. Been explained. Now we go to filter. How do we filter? Let's say, for example, you're expected to filter a specific data by some criteria. You've been given, let's say, as a data engineer, in real life scenarios, a ticket has been created for you. You've had a discussion with your team members, and maybe on when you're having your normal daily stand-up, and you've been given a ticket to work on a particular data, considering that you have to make sure that you extract or filter the data by particular criteria. For example, let's say you have to filter this data, anything that is less than or equal to 20,017, you need to filter that data that way. So you create a ticket, work on this particular data, apply your filter, and you do it. So how do you do the filter? So you have data type df, data type underscore df. We have filter. This is still data frame. Let's see how it comes. So we're using this data frame here. So we're using this data frame where we converted the column name. We changed the column name here, so we're using that one. The reason why I'm taking you back is to explain, you'll be wondering that before we use data underscore df, now it's changed to data type underscore df. The reason is that here we apply with column rename and we chose a variable name for this data frame. So we are making reference to this. So we now apply filter, the data frame itself dot the column that we're interested in, the column name, which is the middle age. So we want to select anything that is what? Less than or equal to 2,917. Less than or equal to 2,917. Then if you do that, you see it's gone to 15. Here initially, data, we have 323 rows. But after we apply our filter, by filtering by this number, anything that is less than or equal to 2,017 in middle age, then the rows have gone down. So we have how many rows now? We have 115 rows, including the column name. So from 323, as a result of filtering, to 115. When it comes to data engineering work, filtering is always advisable to be done from the beginning of the transformation when you are cleaning your data. You know, when it comes to ETL process, extraction, transformation, and loading, when you load your data, you start doing the cleaning of the data itself. Cleaning involves reducing noise, increasing the performance so that the code will perform better, we process data faster. I will process the file faster. So you apply all this stuff, filtering, cleansing, removing some things within the data from the beginning before you start doing transformation. So now we have here, we can see it has reduced. In this case of data that you have, let's say you are reading the file and you're able to filter from beginning, you have increased the efficiency of the data by how many? Almost more than 120%, if I'm correct. More than 120%, because you've been able to remove what's unwanted data. You've been able to remove unwanted data from this data, and you have reduced it to 115, that the major one that you are interested in. And that is the major part of data engineering, increasing performance. Find a way to increase the performance of the application that you're, of the product itself, because it will save the company a lot of cost. Especially when you
208.
Sorry?
Did you say by 208?
I'm not sure, but it's more should be like
208.
Is it 208, right?
Yeah, 208, sir.
Oh, okay. Yes, 208 has been taken away from 323, right? So in terms of percentage, I'm trying to explain in terms of percentage. But for the percentage, you have increased the performance of the application by almost at 50%, more than 50% now. Because half of 323 is as 161.5. So that means you have increased the efficiency by more than 50%. So close to 60 or 70, if I'm correct. Or
More
55.
than 50%.
Yes, more than 50%. So you have increased the performance by quickly catching, finding a way to reduce any form of redundancy within your data. So now we have this. In this case, we are applying data type filter by middle age again. So I'm using the same example, different ways of select. Remember the select. So data type underscore df. Then in this case, it's data type, it's middle age less than. So here it's less than or equal to. So in this case, less than. So you can decide to use this. Don't forget, you can do this. In this case, I decide to use it. So you can do it this way, and it will still work. You can decide to take it back this way. if you go back to that, when I was explaining select, it will give you clue on how to, do this, how to dynamically use something similar to this. So now we have this. So in our filtering here, less than, remember we didn't say less than equal to, is 237. So now that's filtering. We've covered filtering. Then we have we are filtering by two different columns, where this column is greater than the figure there is greater than 40917, and two conditions. So it has to fulfill the two conditions, and is this. Remember, you can have condition where you have or. Now, so that's it. So in this case, we are using and. We have our what's this logic? You remember and, or, no, all those stuff is also applicable when it comes to data. Does that make sense? So it's applicable when it comes to transformation. You can use and. In this case, you can use, I remember how to do this one. You use 1 second. From parent, discover this only. Okay, I think it's a difference. Maybe the application is actually wrong. But there's a way you can apply, NAND and or and stuff. So, and you still get results. So all those logic and or, no, be applicable here. So, and at the same time, like you have experience with, SQL already. So you can apply, within Spark, you can do Spark SQL. You can run a SQL query in Spark. So you just create data type, create view. Is either you use create or replace temporary view. They are two different, they do something different, they are similar, but they are a bit different. One is saying that if it's already created, you replace the table. Does that make sense? So we have something called create or replace temporary. Let me see, Spark. Let me show you here. I think it makes sense if I show you something. Okay. Okay. So this is, I was in the beginning when I was explaining Spark, I told you about Python libraries, SQL, Java. So you can do a lot of things with Spark. So Spark SQL, let me use Spark. Let me go to Spark SQL here. In seconds, let me see if we have any documentation here that will be very helpful. Second. Okay. Can you see? Save as table. You can save something. You can save your data frame as table, just like our normal SQL query that you can insert into. You can do a lot. Spark SQL this does show. So you can do a lot with Spark, but I'm looking for create or replace temporary view. Coming. Create or replace view. So you can use create or replace temp. Can you see? DF create or replace. Can you see? So create or replace a local temporary view with this data frame. So you can use this function called create or replace. So in this case, where I showed create temporary view. So you can decide to use create or replace in that case. So let's copy this one, put it in. It will still do the same work. Well, it will replace if it's in existence, it will replace the one that is in existence with a new one. So it will overwrite, the other one. Can you see it's working? So, but if I do incoming creates. Okay, sorry. Oh, why? Okay, anyway. So let's go back to what we use. So create or replace temporary view. So we put the name of the view.
So I think why it did not work is because the file already existed. That's why the create alone didn't work.
Exactly, yes. Already is yeah. Because of the yeah, okay. 1 second. Maybe I didn't count. I think I didn't count. Thank you so much. Because that was what I was trying to explain. Because if you use create temporary view, it means that you cannot overwrite. It will override the currently existing view. So in order to fix that, you use create or replace. So create or replace, we check if it had already existed, then it will replace the existing one with a new one. So most of the time, I will advise when you are using create or maybe create view, use create or replace temporary view. So now when you do that, it will create a view called SOM data underscore group. Then you can now do data frame because of Spark does SQL selects all from the view where middle age is what greater than this and children is what greater than this. So it's still doing the same thing as this. So they are both the same. They are performing the same function in this case. Does that make sense? So you use Spark SQL here, then here you can read your data and that. So we have something called start with. This start week is very, very good when it comes to filtering of data. Because let me give you an example. Let's say in your data you have some figures that are ID. Okay, let me say ID 1, 2, 3, 4. We have another one called IS 2952. We have another one called ID 1, 2, 3. In this case, start with, if you say start with ID, it will catch everything related to ID. So anything ID, it will take it, it will filter it and drop this. So that's how it works when it comes to start with. So anything that starts with South, in this case now, South, we have everything is filtering everything that starts with South. We have South Lakeland, South Tyneside, South River, and South Holland. So we have that. It's going to filter all of them out. So that's how start with works. End with is good too. I actually love using end with when it comes to, I use it for data type, a file, when I want to read file. When I want to read file, for example, remember when we did, I'm trying to take you back to understand how we use all this start with. Okay, let's just, don't worry, let's forget about that. Then let us go back again. So let's do start with, what is it? So we have start with South, we've done that. So end with Y. So anything that has Y in LA underscore name will be filtered out. You see everything Y here. If you see Y here, it's going to pick it up. But another way is, yeah, okay, it's going to pick that up. Then we have contains. If it contains Y. So this one is end with. Remember, it's end with. So if it has Y at the end, it will pick it up. But in this one, contains means anywhere, even if it's the first letter, the last letter, middle letter, whatever, is going to pick Y. So contains Y is going to pick that. And if we run that, oh, let me check this. So if we run that for this, contains Then we pick that up. Then to pick everything that has Y here. Then we have something called like. I love this like. Like is so interesting. In fact, in SQL, you use more like. Like is very, very good when it comes to SQL queries. It helps you to filter some maybe values or metrics that you can't actually filter normally. But using this like, you can easily pick that. And when you are using like, if you see here, like, after using the function like, I use EO6. So I'm looking for anything related to EO6 that starts with EO6. So, but it must be EO6. The first 3 letters must be what? EO6. Then the percentage means anything after. The percentage at the back means anything after EO6. It doesn't matter. So if I do EO6 now, if I run this code for LA_code, so it's graphing everything EO6 all true. But what if I say I want something like percentage and I do 6 at the back? Let's see the magic. I put, so that means I'm looking for anything, either it's EO6, EO7, it doesn't matter, but it must end with what? 6. Can you see? Everything ends with 6, 6, 6, 6, 6. Let's say everything must end with 5, 6. Let's see. 5, 6. How many? Let me see. Can you see? Only 2. 5, 6, 5, 6. Like, so it will pick anything before that, but it must end with what? 5, 6. Anything before, either EO6, EO7, wherever, but it must end with what? 5, 6. So you use like to capture that. You use like to capture that. Then, remember I was talking about create or replace temporary view the other time. So here, so I've given an example, create or replace temporary view, and I created a SQL query. So passing a different view is_df, which we now use as select all data frame equals to spark.sql, select all from the temporary view we created here, where LA name in helps you to select maybe some values in your data. So in this, capturing that and picking that up. Does that make sense? So I think that's then another example is that you can actually also create a list. You can create a list like this. Create a list of what you want to filter, normal filtering, filter data type LA is in. I've used this in different projects. Is in. If what you're looking for is within the list here, it's going to filter it out. Just pass the name, list name, which is the variable name for this list, pass the name here and show. Then you get your result. Anywhere you see Middlesbrough in LA_name is going to pick Middlesbrough, Wickham, Stafford, Lambert. So it's going to pick all of them and we filter by that. Then we have sorts. Somebody asked me a question when I was doing normal Python, not the Spark side, how to sort, and I show an example how to sort by ascending, descending. So in the case of Spark, you use sorts, but it's going to use sort by default, which is ascending. So by default, it's going to use ascending. So use data frame dot sort, pass in the name of the column that you're interested in, which is this. Then we do it by ascending. Can you see from the lowest to the what? To the highest. Does that make sense?
Yes, sir.
Okay, thank you. So now we have also how to apply ascending. Can you see ascending and descending? So here I'm applying ascending and descending directly, but by default, it's going to give you, don't forget ascending, but you can decide to use ascending and descending. So here I'm using two different columns. So I can also, here we are applying children. I can decide to take this off and do ascending for children here. So let me do the children. So the children here, descending. Let's do descending. Oh, sorry. Okay, so let's do descending, descending. Okay, good. So if we run this one now, you see the ascending is here. Then if we do descending here, look at it. Descending is what? The highest will be 244,682 down to you see 628,585. You should be able to see that. Okay, this 11064. You will see 11064 here under children. 110. So we have it arranged. So that should be fine. So we have, let me see, 9248. So okay, brilliant. So starting from, yeah, so that's how it works. So let's go on to the next one, which is order by. So you can order by. So order by and sort, they are the same. To me, they are the same, but it depends on how you want to apply it. So you can decide to order by the column. You consider the first column before using the other column. So you order by this first. After considering this, then it will focus on the other one. So this is the ordering. So it's like you are grouping them. Just like we have SOM. In SOM, we have projects, we have some people that are doing project management, we have BA, we have data analysis and engineering, we have software testing. So we can decide to say, okay, it's compulsory for everybody to attend software testing. So we can order by people that attended software testing and also attending what data engineering. Can you see? So you can group people, segment them, classify them in different groups. So some people will be classified under software testing BA, software testing project management, software testing data engineering. So you use this particular way to sort things out. So it will help you to organize data correctly the way it should appear. So that's the order by. Then here you can use your pandas, when in Spark. So you can convert from Spark data frame to pandas. You can apply data type dot to pandas, and you can start working in pandas. You can do whatever. If you are familiar with pandas very well, we're not covering pandas here because we don't have that, and we don't have that time. But you can start doing anything related to pandas here. Underscore pandas. So let's say, for example, you want to create a new column in pandas. New column equals to new column equals to EF to dot LA underscore name. So you can create additional column, call it new column here. It will still work. If you run our Panda code, you see another column. Can you see? So you can do a lot of things here. You can do multiplication. If you are very good with pandas, you can start looping. You can do a lot with, Oh, yeah. So it's so easy. Here within pandas, you can use I think you can use dot columns, no, df underscore w or yeah, good for df underscore to the for file. Honestly, for file df pandas dots. Um, oh, sorry, file. So we in the items prints K. You see, so you see, you can start doing where pandas start using your sorry, you start using pandas data frame here. So we're moving from Spark data frame to pandas data frame. You can still do a lot of work. But one thing about limitation to Panda is that it's very slow. It works for not a large amount of data. That's why you see some companies are now migrating using pandas data frame to Spark data frame when they are dealing with huge amount of data, up to like maybe from 2 gigabyte, 3, 4, 5, 6 gigabytes. They prefer to now use Spark data frame to undo that particular task. So if you are familiar with Spark pandas, makes you to do ETL process just like Spark, but not large amount of data, because it will slow down the application. So that's how it works. So you can start doing whatever with your pandas, use your normal Python that we've already treated without using any library. So all you just do is to, import pandas and you start doing some other things there. So that's an example. It's just to show you how it works. You see, remember in our Spark data frame, if we want to create a new column, what do? If we go back here in Spark data frame, if we want to create a new column, we normally we mention the column. Remember here, we want to create a column here. Where is it again? Let me see. Brilliant. You see, here we want to create a column using this. Can you see? So then we apply this, but in Pandas data frame, creating a column I think it looks very easy, but you can do a lot with Spark data frame. You can use mapping. So in Pandas data frame, you can create a function just like we've been doing. You can do mapping and, do a lot. So that's the idea. So that's a diversion a bit, but just for you to know that you can change from Spark data frame to Pandas data frame. So I've shown you the results here. Pandas data frame here, and I think that's it. Any question? Any questions so far? I'm expecting question.
Right? Can you hear me?
Yeah, I can hear you clearly.
Oh, okay. So my question is, I don't know, maybe I've missed this along the way. Anytime I open a new notebook on Google Colab, do I need to import all the libraries, the Spark and everything before I can start work?
You don't need to do it. When you open, okay, like for example, you see, I already have this in my Google Colab. I just opened it. All I did was I went here, did open notebook. Please, can you mute yourself? I'm getting a feedback. So I click on open notebook. Then from here, I was able to, load my previous section notebook. And that's it. So you don't need to, but I will advise you keep saving it. It will save automatically, but please just maybe save it manually. And sometimes, if you like, you can do download. download the file and upload it back. So if I download this one now, I can decide to upload it. Upload from here. Then I'll go to my browser and go to download and upload the file if it's not in yet. Do you understand? So you will still get it back. So you can decide to download it on your computer and later upload it back just to keep record. If you know that it's not saved, but I'm very sure you'll be able to save it here. Is that okay?
Thank you. Yep.
Okay, thank you. So we're going to have a quick break, but before we have a quick break, I should have explained another aspect of what we're doing, which is AWS, and I think we're going to round up today. So you'll be able to, I'll show you how to, if you have AWS environment, let me first explain so that we'll go for a few minutes, then you configure your environment and let's see what's going to happen. So for AWS is a cloud environment. You see, we have on-premise data, we have cloud now. Most companies are migrating to cloud environments. They are using Azure platform, they are using AWS, they're using GCP, Google Cloud Platform, some are using Alibaba platform, some are using Cloudera. We have DataWorks, we have SaaS, we have lots of them. But the SaaS one looks like on-premise, but you can still extract data from there, but it's not that dynamic. So, but most of them are migrating to cloud environment. And the reason why we're covering this is to get you familiar with, the cloud environment itself. And if time permits us, we'll be able to maybe do a bit of ETL, then do few things before the end of today. So, but I will advise, if you don't have AWS account, go to AWS, yeah. AWS, I'm coming. I don't want to open it already. AWS link. Okay, I'll be sharing. Okay. While we go for break, I will share this with everyone. So you can just get sign in from there. So I will share this with you. So just go through this console.aws this and get it configured. It will ask you for your credit card or debit card. Fill it up, but I will guide you also on how to check the billings so that you will not be charged. So we're starting from this, working with AWS, then we'll be doing this. So please, for now, we'll go for a few minutes break. We can come back in the next 15 minutes. Take your time, just get this one configured. Go to this console link, this S3 link, HTTPS, this, then let me show you. Can you see? It's taking me there now, but I've already logged into my account. So I think it's taking ages. Okay, what I can do is that, okay. My AWS account, I can log out. Let me log out here and you see how it works. So just go here, my account and AWS Management Console, then you create a new account. Go here and create a new account. So go here and create a new account. Then you fill in your new email address, put the name of our account and verify your email. But along the way, it will ask you to verify with your debit card account. It won't take any money from your account, but it's just for verification in case you use the service and you don't want to pay so they can quickly grab your money. So that's how it works. Now we'll continue from where we stop. We'll continue with AWS. So AWS is a cloud environment. And most companies across the world are all moving to cloud environments. Bloomberg, Facebook, that's Meta, all these top companies, they are all moving everything to cloud environment. And don't forget, data is incremental, is increasing every day. And companies are now looking for a way to make sure that all these data are kept somewhere. You know, all the files, all the data that we have, they are stored somewhere safe that they'll be able to have access to. Number one, the reason why they have to store those data is for historical purpose. They can make use of those data and get insights from the data. Don't forget, now we're moving to the era of artificial intelligence. Remember, data are getting more larger, and if they are getting larger, that means they will go in form of petabytes and terabytes. What do you use for that? You use Spark. If you are interested in artificial intelligence area, you will still use Spark. You use machine learning with Spark because you'll be able to train and test your data using PySpark. So in this way, you have advantage when it comes to using working in any organization. When they see that you have experience with Spark, several organizations have started using this Spark more now. They are using Spark because they emphasize that they can see the future that, now their data is going to be getting more larger and larger. How do they deal with it? So they have to start adopting a Spark data frame to get all those data transformed. So if you're lucky, if you already have Spark experience, congratulations. And we advise you to also expand on that and, build on that. Now, so let's move to AWS, how to create AWS accounts. I've shown you an example. I say you should follow that link. How many of you have opened the accounts? How many?
Yeah, I have it. AWS account, sir.
Oh, you have AWS accounts. Who else again?
Done.
I just opened mine now.
Okay, have you used the debit card to
Yes,
verify?
they debited me.
Okay, they didn't take any money from you.
They did.
Oh, really? How much? £1?
No, not up to £1.
Yes, I guess. I know it's not. Yeah, so just to verify your account, and that's it. Then once it's verified, you can start using the account. So the learning outcome for today is to understand how to create AWS, understand how to create S3 buckets. Hopefully, if we touch Glue, I will be happy just for us to get, because now Glue is getting more attention now. Glue is getting more attention. EMR is getting more attention. SageMaker for machine learning on AWS is getting more attention. AWS Lambda, which is for Pandas data frame, is getting more attention. So you use Spark within Glue. You can use Spark. You can use Pandas also with it, but mostly Spark. Glue is very good when it comes to large amount of data, and that's where we're covering this. So when it comes to Pandas data frame that I mentioned the other time, when you're working with AWS Lambda, you'll be able to use Pandas data frame. So, but it's out of the scope of this particular class. So we'll be covering how to, create S3 bucket, how to upload file into AWS cloud environments, how to get hands-on experience extracting, loading, and transforming data in the cloud. Hopefully, I should be able to cover this if time permits, because we have how many hours left? 2 hours left. Understand ETL case study on AWS serverless application platform. S3 buckets. What do you mean by S3 bucket? It's object-based. It consists of the following: key, the keys, and value. We have keys and value. So key is simply the name of the object. That is the bucket name. Value is the file. So it's simply the data and is made up of a sequence of bytes. However, the focus should not be on that, but the main focus is understanding how to load the data, what are the things that are important when it comes to S3 bucket, and what you have to focus on. So now we have how to sign in. You sign in, choose AWS S3 service under services. So let me sign into my account here. I already have the account. So go here. So account saved there. Oops, okay. Okay, so that's my account is in. So here, if you see example that I showed, I said when you log in, choose S3 services. Choose S3 services. Don't let me use this material to, it's going to delay us. But when at a point, I will move in the material and show you. So choose S3 services here, S3. And if you don't want to choose S3 service, you can go to services here, go to S3 buckets. S3 buckets. Please go back to this video and watch. You will get it. So S3 buckets. And from there, you can create your bucket. Can you see create buckets? Can you see create bucket there? So that's create buckets. 1 second, sorry. Okay, create buckets. We have create buckets, so you can do create buckets and give your bucket name. So, but before you create bucket, you have to take note of the region that you are. So it doesn't, for S3 buckets, well, you can, can you see it? We have the region. Now I'm in London region here. You can change the region here. Can you see? You can change your region here. So in my case, it's London region. So now it's London region. So you can see it here, AWS region. It's Europe, London, EU West to London. Bucket name, let's say SOM 17. SOM 17 class. I'm not sure if it's going to be SOM 17 class. Now, I've done that. So here, you see, I'm creating a new, I'm putting the bucket name. So I can go on. I can decide to block all policy. That means nobody will be able to have access to this particular bucket, but I can take it off. But at the same time, we have ways that you could assign identity access management to this particular bucket so that it's going to only be accessible to few people that have that role to access S3. Some people cannot download anything from S3 bucket. Some can only view. Some cannot change anything. They cannot alter anything, but it depends on the rights and permission given to you. So now I acknowledge this. I can do bucket versioning. Click on the bucket versioning. You click on the bucket versioning. So I can decide to say disable. I want to disable. If you see the bucket versioning, it means keeping multiple variants of objects in the same buckets. So it's like keeping old record of data or files that we have. So I'm disabling bucket versioning. Then we have encryption. What kind of encryption do I want to do? So I can decide to say, I can disable encryption. Does that make sense? So I'm disabling that. So they're using this, I'm disabling encryption in this place. We have advanced settings also. So you can leave that one and create your buckets. Can you see my bucket is created and it's called SOM class 17. Don't mind what I have here. I've got a lot of resources there. So yeah, don't be distracted. So let's open the bucket now. So SOM class 17 class, that's the bucket. So in this bucket, I can load my file. I can create folder paths. I can do a lot in this with these buckets. So I can create a folder in buckets. Don't forget, this is the bucket name, SOM 17 class. I can create a folder under my bucket. Let's say SOM data CSV. Let's say CSV, SOM data CSV. Let me create it. Can you see the folder? I can go here. On the folder part, I can click on this folder and upload a file into that folder. So let's say, for example, I want to upload what we have already, UK data here. So I can upload it here and get it moved to our S3 bucket. It's so easy. There are a lot of things you can do with S3 buckets. It can accommodate any form of data in JSON format, in XML format, in CSV, in Excel, in text, wherever format you want. It can accommodate unstructured data, semi-structured data, structured data, wherever. So it's a storage. It's flexible, so you can use the store as many data as possible. So you can store as any form of any type of data size, wherever it will go into S3 bucket. You see the size of my data here, 14.8 kilobytes. So here we can check, we do a lot of things with S3 bucket also. We can query our S3 data here, just like normal SQL query. We can rename our objects. We can rename the file if we want, rename the file. I can say, oh, okay, I don't want UK data anymore. Just put the name as this UK data. Can you see? I've changed it, UK data. I can decide to check here to calculate total size. Total size is 14.8. So I can calculate total size. What's our total size? Can you see? 14.8. So you can do calculation like that. You can do just simple SQL query. Go here. You do query with S3. Select what kind of format do you want? CSV, comma delimited file. Output, how do you want the output to be? In CSV, comma delimited, then I can decide to remove this limit, just the normal SQL query. Take this one off as S. S means you are naming this one as a new, giving it a new name. So we can run the query. And if you run the query, we have our data here. Can you see? Everything is in. Can run just simple SQL query within S3 to test your data. And at the same time, you can also, a lot of things you can do with S3 buckets. You keep record, like I said. You can keep your Python script file, if you are dealing with some of the, like building data pipeline, not the writing of the script itself. We have the DevOps aspect, which we are not covering here. Is a separate something we do. We actually do separate training on that. But that one is a paid one, so it's different from this. Now, so you know how to have access to, open the file, you can check your data, you can download here, you can copy folder S3 parts here, you can copy it. If I go here, you can see the link parts. Can you see? S3, SOM 17 class, SOM data, CSV, UK data. So that's how it works. I think this data has been altered while I was saving. So let me rename back. It should be just CSV. So because I altered the data, not the file. So the CSV. So it's back now. It's now CSV type. So now we now understand how to upload, add file. You can delete if you want to delete. Check this one and delete what? File. Just put, if you want to delete permanently, delete, type it here, then you'll be able to delete. It's gone. So you can go back to that bucket. I deleted folder. So that's how it works. You can create another folder if you want. SOM data folder. Create it here, put your file here, and that's it. So that's how S3 works. I've shown you how to create create a folder, upload, add file to that folder, and also delete. So I don't think we really don't. So let me show you some properties that we've configured. Remember, our region is AWS region, London, EU West 2 is London. So if you go here, you will see different EU West. We have EU West 1 is Ireland. We have EU West 3 is Paris. Then we have EU West 1, EU Central here. EU Central 1. Can you see? So the other information, remember our permission, the bucket versioning, some of the things we configure when we were, creating the buckets, they are all here. Then there's some other notification that you normally do are attached to, it's out of the scope of this class. You can attach to S3 buckets, create events. There are some ways when file comes into S3 bucket, event is triggered. When the event is triggered, it triggers the ETL application, then it will process your data and get it transformed. So you can use mostly events notification here to create that trigger. Can you see? Put object, post object, this. So here you can attach this one to a Lambda function. And so we're not covering that here. So, so that's done for S3 buckets. So we're going to go to Glue. So before we start with Glue, I would like to explain with this slide first. Then we'll start going through Glue itself. So Glue is a serverless application used to extract, transform, and load. So you used to load your data the way we use it in Google Colab. You read the data, you transform the data, and you load the data, and you write it to the destination. That's how Glue works. And Glue can handle large amount of data, like I said. So most companies that are using AWS platform for ETL process, they majorly use AWS Glue to do data transformation. Data transformation. So they also use AWS Lambda for event-driven data. For example, files that are being uploaded through web app upload from API. So AWS Lambda can be used to extract those data, transform, and load, but not huge amount of data, so Glue can actually undo that easily. So, 1 second. Okay. So Glue can actually undo that. So now, Glue is a serverless service used to extract, like I said, transform and load. So it's available when you want to use it. So you can make it to be triggered at a particular time of the day. You can decide to say, okay, Glue, you set your Glue to be triggered maybe 4 o'clock, 5 o'clock, or every day, set the time it's going to work. With the trigger, to just when file is available, when it's time to trigger, it will just trigger and it will do your transformation of data. Then we have Crawler. Crawler helps you to crawl data from S3 buckets. So depending on how, when it comes to data pipeline, building data pipeline engineering, you work closely with data solution architects. You can call them data architects or you call them solution architects. So, and what they do is they help you to design the best application or architecture that is needed for the ETL data engineering process. So they put the architecture in place. Sometimes they don't do programming, but some do programming. But as a data engineer, as you grow, as you gain more experience in that field, you'll be able to know how to build a product, architect the whole structure, get things done. So Crawler helps you, in this case, Crawler helps you to crawl data from S3 buckets. And while it crawls data from S3 bucket, it will create a table under Glue data catalog. So the name of the S3 bucket, the folder part of the S3 bucket will be used as a table name. It will automatically create that when you are using Crawler. Crawler can be used to crawl different data, CSV, XML file, JSON file. But one thing that is very, very important for crawler to perform very well is using classifier. For example, there's some data that if you use crawler, it will not be converted correctly. So all you have to use is to use a classifier. So a classifier will help you to convert the data in the background from S3 bucket and convert it to the expected format that will be read by, that will be loaded into the table in the Glue data catalog. We call it Glue data catalog. Glue data catalog is a database. Is under Athena. So crawler works with Athena. If you've been hearing Athena is like a surveillance application to, to query data from database. So we have classifier. I'll explain classifier. So it helps you to, get data in the right format and convert it properly so that you can read it correctly. So we have database. I've mentioned database now. We have, so when a crawler crawls data, it stores it in a table and under a database. We have a database, we have a table. So in this case, this is a database. So some are familiar with data warehouse, where you have data warehouse, we have the database name, we have the schema name, then you have a table name. But in this case, we have database, we have a table. So table is created from core data. Can you see? It's created from, you see an example in a few minutes, then we'll touch that. It's created from core data. So we have glue job. Glue job is where you do your ETL. All the script that we have written. We're loading data frame, we're transforming data. We can actually use glue job with Spark to do that and get data written into the destination, desired destination. Then, so the glue job does the ETL task. So it does the, extraction, digesting data, cleaning, transformation of data, and loading of data. We have dev endpoints. I don't actually encourage people to use this dev endpoints. Or else, if you have an organization or you are using it personally, it's good. It helps you to see, if you are familiar with Jupyter Notebook, it's similar to Jupyter Notebook. So dev endpoint is similar to Jupyter Notebook. You'll be able to extract your data just like Google Colab. It's similar to Google Colab, what we've been using, and it will show all your results. The way we're using show, print schema, you'll be able to do it in that environment. You can do it in Glue Job, but you won't see it directly until you go to some of the data in CloudWatch to confirm what you have, your results. Then we have AWS Glue Data Catalog. So the Glue Data Catalog is the metadata stored for our data set. So it's the database itself. Database for everything we query with Athena. So for Athena, you can use to create database. You create database under Glue Data Catalog. You create table with Athena, just like your SQL query that Uncle Yinka has taught you. So it's similar. There's no difference between SQL and this. Maybe only just few things that I just need to change. But if you understand SQL better, you'll be able to work with Athena very well. So crawler cross an infer schema of our data set and add it to AWS Glue Data Catalog. Then we have Glue crawler configuration for S3. One thing is that when you're in an organization, sometimes you'll be provided with several data in folders, and you need to crawl those data. And immediately use crawler. Crawler will just crawl all the data and create a table for all the data using the folder name that you have selected. But you should be able to dynamically select the required data by yourself. And how do you do that? That is where the crawler configuration comes in. So crawler configuration helps you to exclude some folder paths while you are creating a table under Glue Data Catalog. So it helps you to undo that. So it can crawl multiple data stores at once, and that's why you have to put the exclusion. I will explain the exclusion here. So after data stores are crawled, the crawler creates an update table in Glue Data Catalog. So immediately data is crawled, it updates the table in Glue Data Catalog. So it will override the one that you have there, and it will create a new one. In fact, mostly when it comes to data engineering work, mostly you drop all the tables, you run a script to drop all the tables and create a new one to include. Don't forget, your S3 bucket is a storage for data. So whatever data you have in S3 bucket, you can read everything. So it makes sense to go through all the data catalog, the table, including the database, create a fresh database. Then you create a new table that will accommodate new data, updated data. And that's how it works with AWS Glue Crawler. So crawler can also be used to list data stores in MongoDB. If you have experience with MongoDB, you can use it to read data from there. You can use it to read data from DynamoDB. You can use it to read data from Redshift using JDBC. So you need to use this particular stuff to have access to that Redshift, and including Snowflakes. If you are familiar with Snowflakes, should be able to do that, because Redshift is a data warehouse where you store different data. So setting crawler data store, choose your folder path. Remember, I showed you how to bucket name SOM17, folder path, the file name. So you'll be able to create your crawler. So let's do something interesting. Before we continue, just a warning. Please, when you create your crawler, immediately delete it. You will incur charge, but it's going to be very tiny amounts. So please, I will advise you, make sure you go to your billing. Your billing here. Check your billing, AWS billing. Can you see cost and calculation bills? So you should be able to see your bill there. Can you see? My bill is forecasted as $3.8, $3.1919. And what's the service? Yeah, so sometimes I use this because I store data there. So sometimes I still pay little amount of data, amount to just keep, but not that bad, like £2 something here. So now check your cost here, check your bills here, go to bills and payments, check everything, make sure that you are not being charged. I remember that at a point I was charged like £150, which I had to quickly, I paid the first one. I didn't use the next one, but I had to call the customer support, and I told them, I've not been using this service. I think I mistakenly left it, and they listened to me and they refunded my money. So I didn't pay for them. But please don't let it get to that level, because when
That was very kind of them.
I had a very kind, to be honest. I wasn't expecting that because I needed that money. And they took like almost close to another £180 or 150, and and they refunded it. And so I was really excited. So please be careful with the billing, especially for Glue Crawler. Glue Job Crawler, they can consume a lot of money. So that's why it's serverless. But at the same time, please, even if you leave it, it will still be charging you. So be careful, check this billing and cost very well. Check your details there and that. So now we have our S3 bucket. So our S3 bucket, let me see, SOM17. So you see I have SOM16 here. SOM17, SOM data folder, remember? And let me put the file here, SOM data folder, and let me put our CSV file here. the quick access data. Okay. So quick access data. So I've done that. Now, let's try our crawler. We're going to work with crawler now. So let me open a new tab, duplicate. So I'll go to glue. So this is our glue. There are some things you still need to configure, which I will show you. So we have our crawler. So glue data catalog. Let's check here. You see the crawler here, data catalog. This is ETL for glue job. So I can do glue crawler. I can take this crawler and start creating crawler now. Let me create my crawler. So I can do SOM17 crawler. SOM17 crawler. Good. So is your data already mapped to glue table? No. So I want to get my data now. Data store in S3 buckets. Remember I was talking about, if you remember this slide, I said you can crawl data from where? From data store in S3, MongoDB, and DynamoDB and Redshift. If we go back here, you see everything is listed there. JDBC, DynamoDB, MongoDB, Data Lake, Iceberg, the UD table store in S3. So in my case, I'm using S3 bucket because I'm loading data from there. If you store your data in DynamoDB, which is NoSQL database, you can extract data from there. So here, choose S3 buckets. You don't need network connection. Then in this account, in my account, so you can also load data from different accounts. So in this account, so I can do browse my buckets, SOM17, remember, SOM17, choose, and this. Remember, look at this. Please check the instruction. Read the instruction there. All folders and files contained in S3 path are crawl. For example, S3 file bucket folder to crawl all objects. So you see, it's putting slash at the back. So I'm putting it there. So now I'm cool. Then it say crawl all subfolders. So I can decide to crawl all subfolder now. Now remember, I wanted to say something, but I paused a bit and I have my reason for pausing. Because we have not gotten to this level of exclusion part in glue crawler. So exclusion part helps you to filter any form of noise in your data or prevent some data, increase your performance of the application, then at the same time, remove any form of noise from the data. There are not some data files that you don't need. Because if you include those data, what will happen? It will slow down your system now. You understand? So that's the idea. All we are doing is to increase performance. A data engineer, once you've been there, after knowing how to write a code, you need to focus on increasing performance. Because by increasing the performance of your application, you are saving the organization a lot of money. Even the little thing you do, you don't know what you are doing. Sometimes you modify your code to process data within, let's say, from 10 seconds to 2 seconds. You have saved the company a lot of costs. Maybe in millions, but you don't know. In millions. You will wonder that, but you haven't done something much. You just modify, but you saved them a lot. Imagine they have customers coming to use that service and they are spending maybe 20 million pounds on that service. Maybe you saved them like 1 million pounds or 3 million pounds within that just 1 year with your little modification. Well, you understand? So you save them and, and that's how it works. So using crawler ignores some files parts in the S3 bucket. It reduces the number of files that crawler needs to list. It increases the performance of the crawler and it reduces the crawler runtime. So with the exclusion part, I'm not going to use it now, but I'm showing you here. You see, exclude file matching this. This is how you fix the exclusion. So let me go on and S3 bucket. Close this. So you see classifier. I was talking about classifier here. So for example, if our file maybe comes with a different format that is very difficult to crawl, you can just add new classifier. You create your classifier, can you see? So you can crawl data in Grok, XML, JSON, or CSV, and it will get it processed. So that's the classifier. So let me take this off. So let's continue with this and let's crawl our data. We have something called IAM row. We create a new IAM row. IAM row, it gives you row permission, to, should I say, it gives crawler the permission to access S3 buckets. It's like you are using crawler. Crawler is part of glue data glue component, but you need it to go and get data from S3, which is the storage S3 bucket. So it needs a permission. It's like, as an individual, you want to visit somebody you have not met before, you give the person a call. That, oh, hello, I'm this, you introduce yourself, this is this, I was sent by this to come and visit you. Oh, okay. Oh, yeah, there. Sorry, one second.
Please come to
Yeah. So now we
I
have.
collect all those things from you, Paul. You will not rest.
Please, when you're talking, please mute yourself, please. Yeah, remember we're posting it on YouTube. We're not sharing it on. So now, we need to, when you're communicating with the person, you introduce yourself. Oh, maybe you have not met the person before. You say, oh, I was told to call you, visit you. Maybe the other person would have said, okay, I'll be sending my brother or sister to you, this and this. His name is this, her name is this. So, you've already created a connection. That's a permission on the zone. So if you call that person, I'll say, oh, okay, my brother said I should come and, drop something, or I should come and collect something from me. The person will know, oh, okay, good, don't worry, just come this time, I'm available. If you come outside that time, maybe you won't be able to meet the person. So the same thing applies to this IAM row. IAM row gives the S3 and the caller permission to access all the files in S3 buckets. To access all the files in S3 buckets. So the file in S3 buckets, you can use this IAM row to do that. So let's go to create. I'll create new IAM row. If you want to create IAM row, you can decide to do IAM here. Go here, go to IAM, or I can decide to go to here, create new IAM row directly. So here I can create my IAM row. I use the same get started. So EU West London. So I can create my IAM row here, and but what I will do is I'll prefer to use here, just go to create IAM row. So can you see suggesting the service row? It's like AWS Glue service row. Let me say SOM 17. Create. So it has created that row. So we have this row now. Now let's see, let me go further now. 17 row. So let's create we don't have a database. Remember, we need to create a database. So I can call it SOM 17 database. Create database. So I've created a database, which is a SOM 17 database. Let's refresh this. The database will pop up. Can you see? SOM 17 database. Then we can set our advanced stuff. Advanced, how do we want to, get the data? But let's leave this one. Then crawler, how do you want the crawler to run? I told you it can be driven by an event. So you can decide to set the crawler to run hourly, daily. Oh, go there daily, go to my S3 bucket, crawl the data, set the time you want the crawler to pick up. Maybe start by 1 o'clock, starts 1 o'clock, 1 hour, 41 minutes, every 1:41 every day. Go to crawler, go to S3 bucket, crawl the data from there, get it available in S3. So you can do that. So in this case now, I'm just going to do on demand. On demand means wherever you want, whenever you want. When you want, you can go there and just run it. So crawler database, can you see? We've sent that one. We've created our database, then we create our crawler. Let's see if it works. If it doesn't work, we know what to do. So we've configured that. Remember, we have captured our folder path. So let's run our crawler. Our crawler is running. So it's running here. You see the running. So if you want to check it, you can go to crawler here. This is the crawler. So it's running. It's running. So the crawler is running. It's calling data from S3 buckets. And remember, when crawler finish crawling, we have our database already here, remember, and we have a table. So table is going to be generated here. And the table, remember, I said something the other time, SOM 17 class, SOM, we expect the table to come with SOM data folder because it will use the folder in S3 bucket as the table name. Can you see SOM 17 class? Can you see SOM? Oh, okay. SOM 17 class as the table. I think because I use this. So what I will do is that I will change the folder paths. I will delete this crawler. I think he's expecting me to. 1 second. So SOM 17 class. So I will change the configuration of the crawler. So so it's done already. So, but I can reconfigure it. So I go to action, edit crawler. So edit crawler. So it's using, can you see it's using SOM 17. So I want to change this, edit it, SOM 17 slash SOM 17 slash this. So this is what I'm interested in. So slash this. So now let's update the crawler. That should be fine now. So I'm updating the crawler now. Oh, say crawler to update. Okay. Interesting. Okay. And why? It's a error. Cannot update running. Okay. So it said that it's running. So let's stop it. Saying it's running. So let's check the crawler again. So it's stopping already. Good. I think it's done. So let's update after it stopped. Edit crawler. And let's go back here. Edit. Go back. Put the name again. Update the crawler. So it should be fine now. Let's update it. There you go. It's done. So let's run our crawler. I think it's running now. So let's run the crawler. Run crawler. So crawler is running. Let's go back to the table. So we expect, like I said the other time, we expect the table to come with SOM data folder. Remember, because we didn't include this SOM data folder, it captured this as a table name. So we're interested in this as a table name. So now let's check what we have. So let's refresh. Let's refresh. It's working. So let's see. Oh, it's running. Can you see it's running? Running. So let's see our table if it's generated. Let's check if our table is generated. I think we're still running. Let's go to crawler. Let's see. Running. So let's wait for it. So when it's done, it will show stopping. Now, I think it's done. Can you see it's stopping? So let's check our table. Should be fine now. Can you see SOM data folder? So that's what we're expecting because of the part that we picked. So you see, so it's generated here now. This particular one now, we can query it with Athena. Can go ahead and query table. Let's see. Athena is a serverless application also for querying data. Can you see? If you remove the limits, I'll run the script. Can you see? You can see the data. So like your normal SQL, select all from this and you get this. At the same time, you can also maybe create a table from here and load data from S3 buckets directly. So it's doable if you want to do that way. But it depends on what you are doing, depends on what solution architects have said you should do. So if solution architect decide to say use crawler, go for it. If you can also challenge the solution architect to say, okay, why can't we just go for this option or different option? But that's fine. But let's move on. So that's the query. You can see we're using SQL query there. So it's not different from the SQL query you know. So this is the database. This database, data is stored under this. If you open here, can you see under this database, SOM17 database, we have a table. You can have several tables under the database, which you are all familiar with database, so it should be fine. So that's how this works. Any question? Any questions so far?
No, please.
Okay, so please practice, practice, practice. Don't forget, I'll keep repeating it. If you want to really grow when it comes to data engineering, you know, it's more software. So you are a software engineer already. Because what am I saying? You, as a software engineer, you know, we have data engineer, we have software engineer. As you are a software engineer in data, if I'm making sense. So if you already have software experience, you will understand clearly what I'm saying. So if you've been working as a software engineer or you are trained as a software engineer, you understand that some things that are completely related to what you're doing already, but not in data perspective, if I'm making sense. So, but with this, as a software engineer, with the data, with what we have, explained, you'll be able to, expand your career, in data space as a software engineer. Maybe you have software related experience already, but you have not worked with data before. So you should be able to use that experience to, build yourself in that space. And however, if you are just developing yourself, please read very well, explore several materials, and I'm very, very sure you'll be fine. So I've touched crawler. Then there's something called crawler configuration, but I won't be focusing on that because of our time. We don't really have much time, but I need to manage the time. So I will cover here, the last part that I'll be covering is Spark with AWS Glue. Spark with AWS Glue. So Spark with AWS Glue, all what you have touched in Spark, we can apply it in Glue environments, AWS Glue environment. We can apply it in AWS Glue environments. So AWS Glue has something called dynamic frame. We've been talking about data frame. We talked about Pandas data frame, Spark data frame. But in AWS Glue, you can use Spark directly. Good. You can also use dynamic frame. You can work with Spark and dynamic frame together. Both Spark and dynamic. In fact, it's more better, especially when you are loading data from different sources. It's better you combine data frame and dynamic frame together. So AWS Glue is similar to Spark SQL data frame. It represents a distributed collection of data without requiring you to specify a schema data. So dynamic frame can be created using below option. You have create from catalog, create dynamic frame from catalog, and create dynamic frame from options. So from catalog is majorly from Glue data catalog. that I just showed you, where we crawl the data and we saw a table being created. From Glue Data Catalog, sorry, 1 second. So you create dynamic frame from there, and you can create dynamic frame from options. What are the options? From DynamoDB, MongoDB, S3 buckets, and some other, options, especially S3 bucket, Redshift. So you can do that, you see, and other connections are, you see, S3 buckets, Amazon Redshift, and JDBC. Anything related to, you can apply JDBC. I think it's connected to also Snowflake's app. So you can use from options to undo that, from options. So when you see data from catalog, you're talking about your Glue data catalog. From options is S3 bucket, Redshift, and other, anything JDBC related. Then we have Glue libraries. The libraries are very, very important when it comes to Glue. So we have something called import 6, AWS Glue, transform imports. I always advise just have this one. By default, if you generate scripts by yourself, this one will come up. From AWS Glue dynamic frame, import dynamic frame. From PySpark.context, import Spark context. From AWS Glue.context, import Glue context. Then we have from AWS Glue.job, import job. Now, we have few configurations that you need to do. We have args, get resolved, system have job name. So this picks the job name. I will explain what job name is. The SC, Spark context. Spark context is what helps you to run Spark, all the libraries. If you see here, we have Glue context, so we're integrating the Spark context with Glue context. We have Glue context, you pass in the Spark context, which is SC here. Then the Glue context is now you can now access your Spark section. If you remember at the point, I think I used Spark context in RDD. When I was teaching RDD. So it's similar to that. So here, from the Glue context, you can now access Spark section. And I told you the other time, then I said in your Spark context, you can access Spark section. So here we have job. You create a job, pass in the Glue context in your job, then initialize its job name and the args. So we have dynamic frame. So when it comes to data frame, you're familiar with data frame, which I've already explained. For dynamic frame, so when you want to work with Glue, you need to understand how to read data from catalog using the dynamic frame and how to convert it from that dynamic frame to data frame that we are used to. So for dynamic frame, you use, this is a variable name. I've told you several times, you can use any name here. In this case, data source DYF, dynamic, that's why I say dynamic is DYF, dynamic frame. So I use the short form dy and f, DYF. Just like data frame, DF. You will see me using data frame. I was using data frame, DF, data frame. So Glue context that you have here, just like a Spark, you remember Spark.read, pass this Glue context here, then use create dynamic frame from catalog. Don't forget I mentioned this in the here. Create dynamic frame from catalog. When you are reading from Glue data catalog that I showed you here, when you are reading from this catalog, can you see data catalog? You use create dynamic frame from catalog. When you are using other way to source your data, you use from options. So in our case, we want to use from catalog. From catalog, our database name and our table name. There's another thing called transformation CTS. You pass in the variable name here into this, and you are good to go to read that data in dynamic frame. Then after reading that data, just like it's similar to spark.read.csv, then you now need to convert that dynamic frame to data frame. And that brings us to this stage, dynamic and data frame. Dynamic frame can be converted to and from data frame. So you can do it like you convert it from Pandas data frame to Spark data frame, from Spark data frame to Pandas data frame, from Spark data and Spark data frame to Spark SQL. You know how we did that. So it's similar. There's nothing different here in this case. So you can use this to undo that. So for our dynamic frame that we've gotten here, we can now convert this one to data frame. And that brings us to this. You will now use to df that I explained in the beginning of the class when I was talking about Spark. So this is our new data frame variable name. Then we have our dynamic frame. Then you use dots to df to convert to Spark data frame. And wherever we have touched, I've taught you in Spark data frame, you can start applying everything from this stage. You can do dot show, print schema. You can do a lot here. And when you do that, you want to take your data after you've done your transformation, you've gotten everything you wanted. Now, with Spark, then you can convert it back to what? Dynamic frame again. So like I said you can convert from or to. So here now, after solving our problems, we now want to convert it to what? To dynamic frame. We now do this dynamic frame dot from df. This is our data frame. Use the glue context and use the YF here, which is that transformation CTS here as the name. Then from there, you can write this dynamic frame to your output data, just like you are writing our file into S3 buckets. Does that make sense? I know it's not, you won't be able to pick it completely now, but when we start doing the practical, you understand better. So then you do job.commit. When you do that, you are good to go. So any question?
Yes, please.
Okay.
Please, the crawler that we just created, if you leave it running, will you get charged?
If you leave it running, you are not leaving it running, but if you keep it there, you know, we did it only once, right? We ran it once. So we don't need to run because I set it as on demand, remember? On demand. So if I
Yep.
like, I run it. But if you leave it without deleting the crawler itself, the name of the crawler and the database, they will charge you.
Okay.
They will charge for that. So now let's go to the main part of the work. So we've created our crawler. We know how to crawl our data from S3 buckets. I showed you just how to query the data with Athena. Then let's use our glue job. So this is our glue. We want to create a job now. You can create a job with a notebook. If you have a script that you have, you can use, glue, generate this, but you can also do it virtually. I actually love doing virtually. Virtually is good. That is, for this class only. But when it comes to data engineering, you don't do anything manually. But if you understand the process, how it works, in the commercial environment, you'll be able to navigate your way because you know the process, you know what you're doing, you know how to deal with, how data is being processed and whatever. So let's go here. See, it's giving us an example. Say visualize to join multiple sources, Spark Notebook using SQL, Spark Notebook using Pandas. Can you see Pandas? So you can use Pandas there. Then let's do visualize this ETL. So let's create our ETL. So we're using source data. We're using what? Glue data catalog. Don't forget glue data catalog that we created. We have it here. Okay. Now, this is our glue data catalog. Our targets. What's our target? S3 buckets. This is our target. You see where you can write data into. You can write to Redshift. You can write to MySQL, MySQL database. You can write to PostgreSQL. You can write to Oracle SQL, Microsoft SQL Server that you're doing currently. Snowflakes, can you see? You can write data to Snowflakes. You can write to Amazon. Lots of them. SAP. If you're familiar with SAP HANA, MongoDB, Salesforce. You can do a lot here with glue job. So here we have this. And let's check. With this now, it's going to generate a script for us. So, but we need to do our configuration. So our glue data catalog database, after clicking this, remember, I just click on this. Then this came up. So we have database here. There's asking for the table where to read the data, SOM data folder. Remember that we created, that's done. Can you see that check? Green check. So now it's configured. Then targets, how do we want to set our targets? So let's say package file. Do we want it in package file, in CSV file? If we like, we can do that. It's saying node parent, so it say make it available in this. So let's do package file. I mean, I don't really need incoming. So it's going this way. So now Snappy, do we want to use Snappy compression for Snappy? Target location, how do you want us to write the file? So let's say to S3 bucket, SOM 17 class, choose this, but I'd like to write it in SOM 17 class, outputs, I want to call it output file, call it output file slash. So I've chosen that part. It's going to create it directly. So I will save this. You see, it has checked it again. So that means our configuration is perfect. So it's asking for IAM row. So should we use, let's see if we can use this one. AW, you remember the IAM row that we created. So let's start this section. So that has been configured. Then we need to name our glue job SOM17 job. Let's call it SOM17 job, and we can save. Then we saved our job. Now, this would have created a script for us directly. So what I did here is just to use that visual to create a script that we need. So let's click on the script. Can you see it's generated? The script is generated here, and we can edit our script, confirm. So now, can you see the script? Here, all the configuration I was talking about the other time has been generated for us. I talked about this. Arg resolved, everything has been generated, but if it requires modification, then we just modify that. So can you see? Get resolved this. Everything has been configured for us. Other things you need to know about Spark Glue job is that you need to check the job details, your configuration. Can you see IAM role, Spark? There's some configuration you need to take note. Worker type. You remember I was talking about worker, number of workers. In this case, we're choosing GS1. It's for CPU. So if I choose GS2, it means I've chosen 2 workers. So they will do the job faster. But with this worker, with these 2 workers, they will charge the organization. If I run it with 2 workers, I will be charged more compared to if I run it with 1. If I run it with one, it will take me, the runtime will increase. But if I run it with 2, the runtime will reduce. So you see, you have to know which one do you want to go. Do you want to increase performance, or you don't mind the cost that the company will bear? You have to, weigh the two and see which one is preferable. So now, he said you can automatically scale the number of workers. If you see, Glue is intelligent enough, if you click on this, to determine the number of workers it's going to set. So number of workers here, maximum number of workers is what we have here, 10. So here, if I put 10 now, this job will be done, but I can decide to put 1. I only need 1. So the runtime will increase. So job bookmark helps you to track. If you put enable job bookmark, it helps you to track where job stops. It will continue from there. But sometimes this could cause a problem. But sometimes I prefer to put disable. Number of tries. If your job fails, do you want it to try 2 or 3, 4, 5 times? You can write it. If I put 10 times, now if it fails once, it will run again until it gets to 10, then it will stop. So that's it. So I'm putting 1 timeout. When it gets to this time, it should time out. So let me save this one now. Let me save it. And it's saying failed to update. What's the reason? Maximum. Oh, it said it requires GS1 require minimum of 2. So let's change this one to 2. So let's see. Save should be fine now. And you see it's gone. So it's asking us to update this one as 2, the minimum, a maximum, a minimum of 2, not 1. So now we have our job, we have our script. If you look at this script very well, it looks similar to what we have done, but like I said the other time, this is a variable name. This is a variable name. So I can decide to do, remember what I explained here, data source dyrf. I can decide to use this name here. Where's my script? So I can decide to use name, this one. Remember this one, this name goes with this. When I highlighted the other one, it's affected, see? Remember transformation CTS. So whatever I do here, I have to put it there also. So if I do data dyrf here, this other side must be what? Data dyrf. And don't forget, our database is what? SOM17. Our table is what? SOM data folder. Does that make sense?
Yes, sir.
Brilliant. So now we've changed this one from the old name. Let me put it back so that I can copy it so that you can see it. The old name here is here. So we're using this as a new name. Let's identify the old name. Let's find it. Do we have it? So we have it here. So we need to fill it with what? This. Do you understand that now? So you fill this one with the old name, the variable name. Let's continue. Do we have the name here again? We have it here. So we change it to our name. Do we still have it? Okay, that's it. So now, so we changed our source file. So we can now do Amazon S3 here. Just put Amazon S3 here. Then remember CTS, they have the same name, Amazon S3. Let's take it off. Then here, our file will be saved into this path output file if we run it. But here we have not applied, remember we have not applied data frame. So, but let's run it, let's see how it works. Let's see, and let's check the runs. So it's running, can you see our job is running? It's using 2 CPU, GS1, Glue version 4. Here you can do Spark SQL with Glue version 4. Sorry, 1 second, please. Can you give me like 1 minute?
Yes, sir.
Please, 1 minute, please.
Yes, sir.
Yeah, sorry everyone, I'm back now. So I think the job is done. So let's see our file in S3, okay? Let's refresh. Here, folder path, can you see? It's there in output. It's been created, and this package file. Download this file. You can see the file in package viewer. I'm using package viewer. I have a package viewer on my computer. You see here? Package viewer. So you can download it in from Microsoft Store. So package viewer will help you to view any package file. So that's it. So now we know that we're able to load the data. We are able to get it written into S3 bucket in another CSV, in CSV format. Now, the parts that we need to add is now related to the data frame aspect. So it's related to the data frame aspect. So we are going to update the our glue script to capture the data frame that we've been talking about. So these are our scripts. So here, I can now make some changes to the scripts, as you can see. So here, I've already shown data frame here. I've shown this. So I can now, let me go back to what we've covered. So what we've covered, okay. Sorry, so now we can go back to this particular script and maybe pick few things there. So we can pick few things there. We already know our data frame. We can, we know few things there. So we can play around there and see if it works. So for example, I can copy here, go to this place. Before I do that, remember I told you need to convert from dynamic frame to data frame. So I can do data source DYF. So I'll call it data frame, variable name equals to, this one. Then converts to what? To DF. So now that I've converted to DF, so I can now use this data source DF, or I can even call it data DF, just to save me time. So data DF, this is data DM. We have added a new column data here. Then we can do further transformation wherever we have done here. Please follow up. Now, we use lit, so we need to copy this lit here, put it in the script here. As part of, oh, sorry, it's not working, it didn't work. So lit here, let's copy it. Put it here. Oh, okay. Maybe. So from PySpark.secure.function, don't know why it's not. Let me do it manually. Brilliant. So can you see concats? No, so this will work. There's another thing we need to import. That has to do with 1 second, is import dynamic frame, I think. Let me see if we have the import dynamic frame. It's not there. So without that, we won't be able to use conversion there. Remember, blue, I'm coming. Yeah, when it comes to the conversion, we won't be able to use convert if we don't import this. So now we've converted to our Spark data frame. We can apply here. We can now do data underscore df dot show. We can do data underscore df dot show, and if you like, we can still keep data underscore df as the name. If you don't want to keep that name, then we can do further transformation wherever we have done. So I don't think I need to really explain much things here, because we already know how it works, how we do concatenation, all those stuff. So only if I just copy from here. And another thing I need to explain is that in your Glue data catalog, one good thing about Glue data catalog is that it would have mastered your data type directly while crawling. I forgot to tell you that. If you see, Glue has already intelligently picked the name of the file. Is able to recognize which one should be string, which one should be big integer. Can you see automatically? But when we were writing this script, we were converting. But when it comes to Glue environment, when you are when it's crawling data from S3, it will intelligently pick the data type, the actual data type, without you stressing yourself. So it saves you time. That's why in that here, we are not doing any data transformation. But if you see it's not picked correctly, you can still apply cast just to be on the safer side. You know, so that's that. You can see the type of file, the columns, the data type, and so they are all good. So let's go back here. So we're adding, remember, we're adding data column here, data df, data frame dot with column here. Then we can apply, just to make it a bit different, we can decide to do lit dots with column rename. Can you see that? With column rename, the column you want to rename, LA underscore code, if I'm correct, we want to rename it to LA code. LA code. Can you see that? With column rename, LA underscore code is LA code. So now, I'm combining two things together with column and with column rename, but I can decide to split them based on what you know already, just to not to make things complicated. So I can do underscore df, but it's like I'm repeating code twice. So I'll do data underscore df here. Can you see? So it's still the same thing, but to save me time, I can put it here and it will still work. Okay, so now we've done with column rename. We can also do some other stuff here if you want. Can you see with column rename now? So we can decide to use this too if you want. Then we can apply this if you want. We can apply this to the code. Let's do it. So, oh, okay, it's not. So let's stop. I think let's stop here. At least we've made some changes which are very obvious. So now let's go to the script itself. So the script says we can convert from dynamic frame to data frame back. Remember, we can convert from dynamic frame to data frame. We can convert from data frame to dynamic frame. So we need to convert this from data frame that we have after, we've applied our Spark. We need to convert it back to what? Dynamic frame. So how to do that? We need this particular line, which is dynamic frame. Remember, I added a dynamic frame the other time. I said we would need this. That was the reason. So here now, I can do convert from data frame to dynamic frame. To dynamic frame. So I can import this. Our data source from data frame goes in here. Okay. Glue context, and our dynamic frame, this is this. So now we have dynamic frame from df. So this should be fine now. So Now we can now pass this the YF into this. Then we are fine. So we pass this one here. We can keep any other record. So we pass in this new dynamic frame. We pass it here, and we are still retaining other records. So if you run this script now that we've updated, let me see if I have not made it. Okay, yeah, everything is perfect. So if we run this script and we do run, it should be fine. It's running now. Can you see it's running? So it's starting. The last one took 1 minute 52 seconds. Let's see if the time will still be equivalent to 1 minute 52 seconds. Yeah, it's running now. That's why I'm not talking. So let's wait for it to finish. Yeah, so now it's done successfully. Let's see the output. Let's go to our output. Can you see a new file has been generated, which is this is the old one, remember? So this is the new one. Let's delete this. So this is the old one. This is the new one. So let's see if our changes have been implemented. Let's see. Can you see? Can you see it's done? Darlington, Eon says this. Remember data column. Data column has been added. And how do we know? Let's have a look here. Let's go to our script. Remember in our script, we did show here. So we can track the show. Let me open the job. Let me open the job here. Job is at the bottom. Can you see? So here I can track logs. So if I go to the log, I can track it. So it's showing me the log. Let's see. Now, see what it's showing me. Can you see? The initial one does not have the data column. If you remember, you remember we added lists here. Here is where we apply show. And that's what we can see on the CloudWatch. So where we apply show is giving us this. So after that, we added the Leeds, United Kingdom, and we changed the column name to LA code. So from the package file, that we have. Where is the package file? Oh, okay. Let's open package file again. Let me see. So download file. So can you see the package file that we have now as LA_name LA code? Remember LA code here. LA code here. I changed the name to LA code, so it has reflected. If you see the one on the CloudWatch is saying LA_code. So the new one in the package file is saying LA code. Can you see it as a transformation has taken place? So that's the idea. So you convert from dynamic frame to data frame. Start working on data frame, then convert it back to dynamic frame. And from dynamic frame, you write your data into S3. Do we have any question? Is it straightforward? Easy peasy lemon squeezy? Daniel, easy? Okay. So
Not straightforward, but we'll come back to it.
please, better you come back to it. But it's not that difficult. So watch the video, go through it, and see I only apply data frame here. So if you have a lot of transformation we want to do with data frame, just do it here. The other scripts will be the same, right? You understand? So if you have anything concat to integer, put it here. Put everything, arrange it here. All those Spark.SQL, from PySpark.SQL import data type in double type here. If you need it, you copy it, you put it here under here, and you use it. Oops. So now, can you see that? Now, so that's how it works, and that's it. So we're done. So if you want to use other Spark stuff, use it, do your transformation here, the name that after you've used your data frame, pass this data frame to this dynamic frame. You see the dynamic frame is here from AWS dynamic frame, from import dynamic frame. That's why we have this one to convert it to that, to convert our data frame to dynamic frame. So this is the data frame inside here for us to capture another dynamic frame. So I will call this name, like I told you, a variable name will be the same name as transformation CTS here. So variable name here, same as this. If you are following, you will see that they are all the same. Amazon S3, same as this under transformation CTS. That DF_DYF, same as this. So that's that. Please, if you have any question, let me know. If you have any question, let me know. Any questions so far? Yeah, so please practice. You'll be able to be an expert in this field. If you don't practice, there is no way. To be honest, I will stop section. I think we've come to the end of the class. If you have any question, let me know.